Hello everyone, today I will be presenting our paper titled Comparative Evaluation of Differing Levels of Information Presentation in 3D Minimaps on Spatial Knowledge Acquisition in VR. This study was conducted in collaboration with researchers from National Yang-Ming Jiao-Tong University and Clemson University. This is today's outline. We will cover the introduction, problems and contributions, 3D minimaps, user study design, results and key findings, conclusion and future work. Spatial knowledge acquisition is essential for navigation in virtual environments. It involves learning about landmark, route, and survey knowledge within an environment, which can be achieved through repeated exploration or by using navigation aids such as maps. Maps, as navigation aids, typically provide global information about the environment, including landmarks, routes, and overall layout. However, the use of maps in VR often faces issues such as complexity, clutter, and occlusion. Common types of map content include word-in-miniature maps and maps with landmarks and routes. Our research found that there is a lack of maps that strike a balance between the complexity of the word-in-miniature map and the simplified word-in-miniature map. To address this, we proposed user-centered maps, which enhance the user's vicinity by incorporating detailed building information. Additionally, we identified a lack of comparative evaluations on how different levels of information presentation in 3D minimaps impact spatial knowledge acquisition in VR. To bridge this gap, we conduct a comprehensive evaluation comparing a baseline without a map, word-in-miniature map, map with landmarks, and user-centered map. We studied three types of 3D minimaps. The word-in-miniature 3D map represented the entire virtual city. The landmark 3D map simplifies this by displaying only landmarks and routes. The user-centered 3D map further enhanced the landmark 3D map by including ordinary buildings near the user to provide better local context. Each of these designs presents different challenges. Word-in-miniature 3D map can be cluttered. Landmark 3D map may lack spatial context, and user-centered 3D map must balance detail without overwhelming the user. Here, we present an illustrative top-down view of the three 3D minimap conditions. Due to reduced clarity of the landmark labels and the "you are here" indicator from this perspective, landmarks are highlighted in blue, while the "you are here" indicator is presented by a red dot. Yellow arrows indicate the user's field of view. The pink circular ring highlights that only ordinary buildings around the user are displayed. User-centered 3D map includes both landmarks and ordinary buildings in the vicinity of the user. Landmarks serve as key reference points within the model, helping users establish a sense of orientation. The goal of user-centered 3D map is to provide detailed local context, enhancing users' understanding of their surroundings. Additionally, it aims to maintain consistency between the information displayed in user-centered 3D map and what the user perceived in the virtual environment, ensuring a seamless and intuitive spatial experience. In the 3D minimap, each landmark is labeled with its name to help users identify them. We also provide a "you are here" indicator represented by a red dot and yellow arrows. The map was placed horizontally in front of the user at the height of the navel. The distance from the body to the center of the map was set at 82 centimeters, a value experimentally determined through piloting various distances. This distance was chosen to ensure a comfortable view of the map while minimizing potential occlusion issues. The 3D minimap is designed with a forward-up orientation to help users quickly understand the spatial relationship in their surroundings. Interactive features are not supported to avoid variations in how users interacting with the 3D minimap which could affect the acquisition of spatial relationships. We conduct a between-subject study with 4 conditions, recruiting a total of 56 participants. 14 participants were randomly assigned to each condition with a balanced gender distribution. The city model measures 1,100 meters times 1,100 meters and contains 323 buildings, 36 of which are landmarks, while the remaining are ordinary buildings. The task path consisted of 3 consecutive segments. The spatial updating task was conducted while the user wore the VR headset. It was performed each time the participant reached the endpoint of a path segment. At this point, the participant views of the environment was obstructed, and a white bar displayed their prior viewing direction. The participant was then required to point to the 3 target landmarks. The landmarks recall task was conducted after the participant removed the VR headset. They were asked to recall the 9 landmarks they had encountered during the task. In the landmark placement task, participants were provided with images and names of the 9 task landmarks, along with a grayscale map that included the starting and end point. They were required to mark the location of the 9 landmarks. In the route recall task, participants were provided with images and names of the 9 task landmarks, as well as a grayscale map that included the starting and ending points. They were required to draw the route they traveled from the starting point to the end point. Our results showed that the NoMap condition performed the worst in all tasks. Another finding was that the landmark recall score did not show a significant difference among the 4 conditions. Both user-centered 3D map and landmark 3D map outperformed word imager 3D map in spatial updating, landmark placement, and route recall tasks. User-centered 3D map performed better than landmark 3D map in the landmark placement task. We conduct a comparative study to assess mini-maps with varying levels of building detail, specifically word imager 3D map, user-centered 3D map, landmark 3D map, and a baseline condition without a map, on spatial knowledge acquisition through tasks such as spatial updating, landmark recall, landmark placement, and route recall tasks. The results indicate that both landmark 3D map and user-centered 3D map outperform word imager 3D map in spatial updating, landmark placement, and route recall. Furthermore, user-centered 3D map surpassed landmark 3D map in the landmark placement task. We found that adding detailed building information within the user's vicinity enhancing spatial knowledge acquisition. Future work could explore additional advantages of user-centered 3D map, incorporate interaction on the 3D minimap, and investigate long-term spatial memory retention to assess the sustained effect of minimap design. Thank you for listening. I'll be happy to answer any questions.